when you do the validation curve, that time also you like you can pass the parameters, right?
Oh, validation
Curve.
curve.
Yes.
Okay.
Like there
Yeah.
is a API like a validation curve, right?
Yeah.
There also you can pass those parameters. Now then, what is the difference actually? Like
In
when
the
to use what?
okay. So in the validation curve, you are asking, no? Hi, Harshad.
Good morning.
Good morning. By the time everyone comes, you guys can start downloading the dataset.
Okay.
And just download this dataset. And upload. Keep it in your drive and just open a collab file and load it there. Hi, Parth. Hi, Pesala. Are you guys able to download the dataset? Hello, Srinivasan sir.
Yes, I have downloaded.
Okay.
Yeah, you can download.
Yeah. Just load it in the collab. Hello, sir. How are you?
I have one burning question. So about the pipeline method. So hopefully I'll have time to ask that.
Yeah. So like after a long time we are meeting.
Yes. And this time there are quite a few. I mean, this time there are quite a few people who are on the call. So that way I don't know.
Yeah. This time in every courses we are seeing a lot of participation. In MLF like more than 150. It's a common.
So for this MLF, will it be the like is it the same content or like the content has been changed now?
Yeah, for this time we are keeping the same content because some other loads like MLP and MLT. So yeah, we will update that content. And any suggestion from your side will be also welcome. Like you can suggest what new things we can add there. And as we discussed earlier, also like we want to remove that probability part, and we want to keep those in week 0. But yeah, we will
Yeah,
update.
the probability part was a bit, at least week 10 was a bit easy, right? And then I think week 12, we didn't cover that much, but the Gaussian elimination comes later.
Yeah.
So can I ask my question about this pipeline and fit transform?
Yeah.
Okay, so I will tell you, of course, it's silly, but the last MLP week 3 assignment, I had major trouble, right? So I got the practice assignments first, right? And the first time I checked, the answer was right. So I didn't even try anything else, right? And then came to the graded assignment. Then I realized that all of them need predict, right? So in the practice assignments are all based on fit, whatever fit, the coefficient and all that stuff.
Yeah.
And I was not getting any of the answers. I get 0.607 and the minimum value here is 0.66 or whatever. Then I left it for some time. Then I went to the last 2 questions that are again on fit only, right? Using SGD. That also I got it. Then I realized while doing predict, I'm doing something wrong, right? And I tried quite a few things. And first my thought was that was there any issue in the question? I asked and people said, no, they're getting the right stuff. So obviously it's graded assignment, right? So I couldn't ask no more than that. So then I realized, then finally Shreya, after the thing happened, Shreya pointed out that we should do only fit when we scale the test vectors, right? The test features. So when you build the thing, I didn't put a pipeline, right? I had used individually scalar method. For that training set, I use fit transform and get the scaled feature matrix. Then I apply it. For the training set, if I just use transform, it works. Okay, so then I get the right data. So if I use fit transform, that was the issue I was having. So then it kind of got me thinking, is what does pipeline do? Because when you do pipeline, you create the pipeline and you say pipe.fit or whatever, right? Then you may say pipe.score with the feature data, with the test data.
Yeah.
But does it know only to do transform, not fit?
Does that?
See, because suppose you do pipe with fit.
Yeah.
Right? The test data should be scaled, right? That means on the scaling part, fit transform method should be applied.
Right. For polynomial case, you are saying, no?
Yeah, any of the cases, right? Even if you do
Okay.
standard scalar also, I should do fit transform for the scale, no?
Yes.
Okay. But for the test data, for the scalar, for all the transformation functions, only transform should be applied, not fit.
Yeah. Why will you apply the fit part in the skill? You want to predict something, no?
Yes, predict.
So why? Yeah. Why will you apply fit then?
Yeah, but how does the pipeline know that not to apply the fit there, only transform? Because we just call pipe.score, right? We don't put anything else.
Yeah.
Does it happen automatically?
Yeah.
So that was my main question.
Just repeat last part, only like last sentence, what you said.
See, okay, I've created a pipe, right? So standard scalar. So if you see the graded assignment last time, we had to apply standard scalar and the linear.
Graded is meant MLP or MLT side?
MLP.
I haven't checked that. Okay. Just
okay, sorry, I thought you. So it is basically you have to apply standard scalar. You have a California housing data. That's a standard data. You have to apply standard scalar and then apply linear regression.
Yes.
Straightforward. Random state is also given. So then test data, you apply, so you create a pipe, right? The pipe has a standard scalar as a transform and linear regression as the regressor. And then you call pipe.fit on the training data. Implicitly, I understand that the transformation fit transform is applied, then predict the fit method is applied for the regressor. When I call same pipe.score on the test data, right? If I fit transform if I do the standard scalar, do a fit transform, the data goes haywire. I mean, sorry, Rajiv, are you other people getting my question? Or am I?
Yes. So basically, the thing is that pipeline will be used for your training your model. Okay, so that time you pass that train data and like x train, y train. Okay, after you use that pipe dot fit. Okay, now you access that regressor. So that means, say for example, you have only standard scalar and regressor, right? If you want to find out the score on test data, so then pipe, then you access that through -1, right? Because the like your regressor is the second one, correct, in the pipeline. So that way you will get a hand on that regressor. Now for that regressor is already trained because you have used the fit, right? Now that regressor dot predict on test data. Now you send the x test, and what you will get? You will get the y pred.
Yeah, Rajiv, my problem is not with the regressor. My problem is with the scalar method, the transform method.
Sorry, the thing is like Srinivasan sir, I was speaking, but I thought later I saw that I was on mute. Okay, just to interpret, one thing you would have seen there, you are in the dot fit you are using x variable and y variable both. Y vector is also there, but dot predict you are not giving that part, that y part. So I'm not sure what you are asking. So are you able to recollect that? What is the difference, basic difference in that part? Dot fit part.
Okay, let me come back to my question. See, what happens is, while doing a predict, right, I pass the test features, test label.
No, dot for to
sorry, training features, training label. The training features
it?
are scaled with the fit transform of the scalar method.
Okay.
Okay. Then while doing predict, I have to give the test features only with transform.
Yes.
If I do fit transform, I don't get the results. So that is very clear. So that is empirically we have found out, right?
Yeah.
My question is, when I apply pipe, so what I do, first I say pipe dot fit. I give the scaled, I give the unscaled, the raw x, right? Whatever I got from the fetch, I give the x and y, right?
Okay.
It scales it,
Correct.
fits it. Now
Yeah.
I call pipe dot score again with the normal test data without any scaling. Now, how does it know not to do a fit transform, but only a transform for the scaling?
No. If you give that pipe dot score and if you are passing the test data, right?
Yeah.
So that is not the that is not the right way to do that, because scoring on test data you can do through the regressor itself, not through the pipeline.
Okay, when you do the test data, you have to do a
predict.
The example, I don't think they do that, right? They just right away apply the pipe dot score.
No. Pipe dot score, you get a test score and train score, right?
Yeah.
That test score is not on test data. That is the validation that you have a validation fold there, right? That is the test score from there. But that is the data belongs to X train only. You have not shown that during that training, because when you call that fit, right, you will never show him that what is my test data.
Yeah.
And
okay.
that's what you call that fit method and you pass that X train and Y train, right?
Okay, I get it. So let me just hold on to my question. So maybe let's get started, right? I don't know.
I think I know what Srivasan is trying to ask. Okay. May I?
Yes,
Yeah,
yes.
please.
Okay, so what he's saying is, in that question, the question first said you first normalize the data, right, which fit with the standard scalar. Okay, and then we were supposed to apply regression and then find out the score. Now what you must have done is you must have normalized the data, then you fit the normalized data on the regression model. And now your question is, when we find the score on test data, should the data be normalized or the normal test data? Is this what you're asking? Hello.
I know that the test label also has to be normalized. I think I have a minor, I'm not able to get that thing. That I know. I know that even the test data also has to be scaled. Otherwise, you will not get the right.
Okay, now I'll tell you one thing here. Now see, if you create a pipeline in such a way that the pipeline contains first the transformation and the scaling, followed by the regression. Okay. In your pipeline, if you have the your pipeline is equal to scaling, standard scaler, and the regressor, whatever regressor you have. If you fit that pipeline on the data, I mean on the training data, so the argument that you pass in fit, it will be only the data, not the transform data, because the pipeline is taking care of the transformation also. So in that case, if your model is, I have done that in two ways. The one which was explained in the practice assignment in the sessions, and I solved it with pipeline only. So when you create a pipeline, in your pipeline, if you have two things, first is the standard scaler and second is the regression model, right? So if you fit that model on your training data, okay, so obviously you'll pass the training data without transformation because the pipeline is already taking care of the transformation. So in that case, when your model is ready, so when you find out the score, that time you don't have to pass the normalized data. That time you can directly pass the as it is test data. So because your pipeline is in such a way that it already has the transformation as well as regression. But if you do the transformation separately and regression separately, then you will have to pass the normalized data. Is
okay, got it.
Making
so
sense?
I think I'll just hold here. Let's continue with the.
If I could share my screen, I can show you both the codes. So I think that will help.
Or yeah, maybe later we can do that because we will have to start the session. And sir, I would say just I'll try to solve that without using any pipeline by step by step. Okay. So I think after this also still you have doubts, then you can ask directly, or yeah. Okay, in the end we can discuss that part. Still, if you have doubt.
Or you can ask in the forums, I'll paste my both the codes with pipeline and without pipeline, how it works.
Okay, so everyone has downloaded the dataset or what?
Yes, it downloaded.
Yes.
Is there anyone who haven't downloaded dataset yet? So
I haven't downloaded it. This is on the graded assignment. Sorry, practice assignment, is it?
No. Just in the chat box, I shared a link.
Oh, okay.
Okay, so just download that dataset and load it on Collab. Okay, so I'll just try to do that by like a practice question, something like that. And we will, whatever tools we have learned, we will try to implement that in this one. Okay. So yeah, as the sentence is, you just suppose you are working as a data scientist in a big automobile company. Okay, so my screen is visible, no?
Yes.
Yeah, so you are working as a data scientist in a big automobile company. Your company aspires to enter the US market by setting up their manufacturing unit there. Okay, so the company wants to produce their car locally in the US market. So they want to explore the data, like which car is, what are the different range of car is available, and they want to predict the price of car. Okay, so that based on that they can take decision like what models they should make there, something like that. Okay, so the question part is clear, like, yeah, hello.
Yes, sir, clear.
Yes.
Yes, so the basically you have some data and you have to predict the price, and you have to give some ideas to the based on those insights you have to suggest some ideas to your team, so that what is needed to be made there and something like that. Okay, and what would be the price of the car? So till now everyone is clear what we are going to do in this class, something like that only.
Yes. Give me feature selection actually.
Yeah, feature selections, and the basically in the linear regression you are trying to predict the price of the car. Okay, based on the different different configurations, and as you said, like based on the different features, what would be the price of car? Okay, and which is like more common there, something like that. So first part is that import all the libraries whatever you understand and you feel that that will be needed. So everyone is ready with their collab?
Yes.
Have you loaded the data?
Yes.
Is it whether everyone has loaded the data till now or not? Because we can't proceed further, no?
I am getting trouble reading the CSV file locally. So maybe I have to just give me a minute.
Yeah,
But you
yeah,
can
just
continue. Yeah.
no, just take that time, because without doing that, like the whole 2 hours will be waste, something like that.
So how to load the data in Google Colab?
Yeah, just have you kept it in your drive?
Yes.
Yeah, so first import some basic libraries, okay, or otherwise, yeah, just write this part, like just first mount your drive, okay, and once you mount your drive, yeah, just yes, since I have already mounted it. So once you mount your drive, just tell me, like,
Okay.
and the thing is, it depends like where your data set is kept, okay, in the drive, and you can check that after, once you mount your drive, you just open, just click this part, okay, and once you click this part, you will have option to open your drive, and yeah, then my drive, and here, yeah, there will be wherever your data set is there, like for me it is somewhere, yeah, in this folder I have my data set, okay, so here it is, and once you click on this dot, you will get that, yeah, copy path.
Got it.
Yeah, once everyone is ready with the data set loading part, then only we can proceed, because yeah, just everyone just message that done part, because that will help me to understand, yeah, everyone is done with the loading part. Yeah, Trivikram, just take your time, because okay, Deval is also done.
If I just keep it in the wrong this thing, I just does mount, right?
Yeah, sorry.
Just kept it in the main folder itself, not anything else.
Yeah, that is also good.
Just say drive.mount content drive, right? Okay.
So yeah, till now I got 3, 4, 5, 6. Yeah, 6 done. 1 is in waiting mode. What about others? Total we are 20 people today, no? Somewhere.
I get some credential errors. I don't know what I am doing wrong.
Yeah, what? Sorry,
I get
credential
a
error.
credential propagation failed error.
So before, have you mounted your drive earlier?
No, this is
Because
the first time I'm trying this. So
okay.
otherwise, in Jupyter, I just used to copy it. Just copy it from Jupyter, read it. From Colab, of course, I can't read a local file, right? So I have to mount it.
Yeah.
Sir, you can probably try logging in the browser, like logging in Gmail while using Colab and then try to mount it.
Okay, sorry, it was a silly thing because there are check boxes. I have to give permission, right? Usually they.
Yeah. You
I forgot
given.
to do that. Okay, thanks, guys.
Yeah. So one more. At least 10 people. So Srinivasan sir, are you done? Yeah, around 6 people we have got, like who has done uploaded. Yeah, loaded the data. Any other people who are coming will be with me. So can we proceed further for next step?
Yes.
Yeah, one more done. Yeah. So yeah, we are proceeding. So yeah, after the dataset downloading, you can just give me the answer of these 6 questions, these 7 questions actually. Just try to explore the data, like what are the things we have given. Okay.
Sir, can you just scroll up a little bit? I just want to see the command once. Yeah, just one second.
So are you guys able to see the chat box or in the on the screen or not? Hello.
Yes, so we can see your chat.
Okay. So, yeah. Then I should keep it.
So can you just scroll up? I need to see one comment. No. I mean, up totally.
So this part, are you saying?
Yes. Video I forgot to import some.
Okay. Yeah, just for now, like you can import at least you import numpy as np and import pandas as pd. These two is minimum. Like at least we have to import this part. Okay, so Rajiv has reached to the categorical fields. Yeah, so yeah, price is the target level.
Can you post those questions in this chat window so that like
Okay, like that. Yeah.
Those 7-8 questions are there, right? That put in the chat window so that because people might need to see the collab.
Okay. So I'll push that.
Thank you.
No one is values. Yeah, that's also correct. So is anyone facing any difficulty in answering these questions? Like we'll wait, obviously we will wait for a few more minutes. And from now onwards, I would suggest to everyone to just send the answer to me, like privately, because so that this chat box will, yeah, because otherwise I think everyone would have lost the part, like where the question was. So yeah, Deval has completed all the 7 tasks. Yeah, I'll open the code. So let's take out like a number of data points. Is everyone able to get that? Hello.
Yes, sir.
Yeah. So yeah, that is simple and yeah, data set of shape, whatever. Yeah, that will give you the what is your shape of your data. Okay, so here we are seeing that yeah, we have 205 number of sample points and yeah, 26 features, and not 26 features actually. Yeah, one is the dependent variable. So yeah, 26 column we can say. Okay, so the first step what I do usually is like or most of the people do is like they just put it like dataset dot head. Okay, so why they put this? Because based on this only, like yeah, they are able to see the yeah, what are the different features and all the sorry, like the sample of first 5, or some people just put it like dataset dot 5 and dataset dot -5. What my question is, what this minus, if I'll put here -5, what that will do? Anyone just say?
Just -5.
Yeah.
I think it should return last 5 entries.
Yes, last 5 entries.
Yeah, right. Yeah, so it will, yeah, so few people just see like first 5, yeah, see you have like 10,000 of data, so you just take that last 5, first 5, just to get idea. Okay, not something like that. So sometime these are the cleaner data, so not every time you will get this much clean data. Okay, so okay, just we will go just step by step, like how the data science just as a data scientist you will think something like that. Okay, so first you have to understand that the data, like whatever are the things you have you are given with. So first is the car ID, so it would be a normal ID, some kind of ID, like okay. So yeah, symboling, I'm also not sure what does it mean for them. Okay, so car name, yeah, that we are seeing, yeah, that yeah, alpha something model, alpha something model, something like that, Audi 100 LS, something like that. Okay, so car name everyone understand. And yeah, so this fuel type, so yeah, this we can also understand, like yeah, what is the type of fuel the your car is using. Okay, So again, aspiration is there, door number is there, like how many number of doors are there, car body, like yeah, convertible and or hatchback or sedan, something like that. Drive wheel is there. Okay. So like that, you have all the things. So is there anything like who's been you are not getting, or we want to discuss something like that? Yeah, please ask.
So for getting all the feature names, I think we have to we
Yeah,
have
yeah,
some argument feature names, right? But for
yes,
that we need some library. I forgot that.
yeah, we will go to that party. I have kept that, but yeah, just think from just we will think step by step, like yeah, what is the yeah, what that represents. Okay, so yeah, just we are going through that phase, like yeah, we are trying to understand the data, like what is given to us, something like that.
Okay.
Okay, so yeah, door we understood, like number of doors in a car body, like yeah, what is the type of body of car, and yeah, type of driveways, yeah, where the engine is located, whether it's the front or at the back. Yeah, wheelbase. Okay, yeah, then length of the car is given, width of the car is given, car height is given, curve weight, something you term. So does anyone know like what is curve weight? Hello?
No.
Yeah, so curve weight is the weight of the car when it is empty, like something like that. So that's why we say, yeah, the domain knowledge is also important, because with something like that, because we know if someone has the knowledge of this domain, he will understand like what is drive wheel, what is something wheelbase, something like that. Okay, so yeah, that's why we say that yeah, domain knowledge is very important. Okay, so yeah, then it is engine type of what different type of engines are there. So yeah, that is method here. And then yeah, cylinder numbers. Have you guys, actually I want to make it interactive, but I think you guys are not taking that just, so I think I should pass on the like yeah, that question part only, or is it you guys are not interested in this part or something like that, because based on that only,
No,
like
no, we are interested.
No,
We are
not like
interested.
that.
I think domain knowledge maybe not all of us have, so probably that's why.
yeah, it's okay, but I would suggest like yeah, participate, like once you will speak, no, that is what I want, like yeah, everyone should speak, something like that.
Okay.
Okay, sure. Yeah, then the engine type is that cylinder number. You have idea like how cylinder improves the performance of the car, like more is the number of cylinder, yeah, more is the power we generate. So yeah, that engine size is also there, like what is the size of engine, and yeah, fuel system, then bore ratio. Okay, I'll just since most of the people don't have idea. Okay, then yeah, city MPG, highway MPG. So what do you understand this part? Like it is something like that. In the city, it will give mileage or something like that, and on highway, it will give mileage like something like that. This okay. So as you all guys know that yeah, what would be the average mileage of a car? Like whatever it is mentioned, it is more than that or it is less than that on
It
road.
looks more.
It looks more. City definitely more.
Yeah, and yeah, I'm saying that in the we when we buy the car and all, like the company mentions some mileage. So on road we get that much mileage or less than that, something.
Less than that.
Yeah, so it is pretty obvious because that was calculated under ideal conditions. Okay, so here also we are seeing that yeah, on this in city it is giving lesser mileage, on highway it is giving more mileage, because like every time brake and all, applying brake and all, yeah, signals and all, so due to that, so I think it makes sense. Okay, so first part what we try to do is like we just try to see whenever we put our data in some algorithm, they don't have any value of these categorical features. Okay, So our two tasks will be there, like whatever is in the numbers, no, that is useful for us, and whatever is not in numbers, no, that is not useful for us. Okay, so from our domain knowledge, we should just try to reduce the sizes of features. Okay, so what are the different domain knowledge you can think? Yeah, since you don't have domain knowledge, so I think I should skip one part. Okay.
So here what,
Uh,
so these all are features or only some of them?
All are features. All are features. This is the data you got, and you have to make a model, something like that. Just to think this much only.
So then what would be the label, the price?
Yeah, label is your price. Yeah, that is what you have to predict. No, that the first sentence only, like we talked about this. Like data science team are required to model the price of cars. With
Sir,
the
actually, cylinder number should be numerical variable, but it's categorical.
Yeah, that is also true. Yeah, that we can change. So yeah, that is what I'm saying. Like whatever is written in here in that format, no, like that categorical format, no, that is of no use right now. So we have to improve our data set. First thing is that, and just try to reduce the columns. If something is like correlated, you can directly observe something like that. So what one thing I can say here, I can comment here, like a car length is there, car width is there, car height is there. Based on these three factors, I think we can calculate its weight. Am I right?
Yes.
Yeah.
Yes.
Directly related.
Yeah. So yeah, due to yeah, something like that you can think, or yeah, just try to reduce that shape. Okay, just for air, like suppose yeah, car width is there, car height is there. Just we will put some car area that will cover both the things. Okay, or something like that here also, like a city map, city mileage is there, highway mileage is there. So we can put some average mileage by giving some weight to both the factors. That depends. That comes from the domain knowledge. Like so, something like that. And here also there are some relations, but I won't go that to mechanical term. Yeah, so like yeah, like that we just try to do that part. Okay,
So normally for the categorical, it's similar to label transformation, is it? Like if we want to use them, then we convert it similar to label transformation.
yeah, that is also a case. Yeah, label encoding, one hot encoding, that we will see. Okay, but yeah, but before doing that, yeah, few things we should check here. Okay, just at this part I will skip because yeah. So yeah, so first part is like a dataset.info. It will give you a lot of information directly. Okay, so like the data type, how many null values are there. Since see, one thing directly here from here only, like we can comment like since we had 205 number of rows. So here we saw that on an like in the all cases like a 205 non-null values we are getting. So from here only, like we can comment, yeah, there is no null values. Or if it would be null values, then for that we can calculate that, yeah, dot is dot na, or yeah, that row we can just get. And depend on the situations, we can just remove that part. When just give us some idea, like when we should remove any part or when we should keep that. Yeah.
We
Hello?
have when we have less data, we cannot remove any parts, right?
Yeah, one thing
If you have
is,
sufficiently large data, we can afford to remove some part, but usually we don't remove if you have less data. So
yes,
we will
that,
convert that.
yeah. And how can you just change yeah, what are the different way you should think, like to just put some and just replace that any values.
So we can use that min max scalar or k nearest neighbor or something like that.
No, that's completely wrong. Yeah,
Yeah, mean or
Using
median.
an imputer. Using
Impute, right? You want to impute the missing
I
value.
imputer, yes.
Yeah, you can use the mean value or median value, something that sort of.
yeah, that's true. Mean value, median value, it depends on the situations.
KNN imputer.
Yeah, so in the case of like, yeah, just to keep it simple, like yeah, we will just replace it with the mean value or median value, like yeah. So and what it means is like we have got some mileage of all the cars. Okay, So here, suppose just we got the mileage of all the cars. Okay. So what we are assuming is like if it is not here given here, no. So it will be average of all these parts only. Like yeah, it will be average. Like whatever the other cars are giving, no, that we just keep it average. So for the in that case we put it as mean. And when should we put mean and when should we put median value here to replace the NA values?
Yeah, depending on the existence of outliers.
Yeah, that is also true. Yeah, when the more number of outlier will be there, so then we'll replace it with the median values. Yeah, that's true.
Median value.
Yeah, and yeah, when we don't have outliers, then yeah, we can replace it with the mean values. Or if we have large number of data, just we can simply ignore it.
We can also check the variance, right? To understand whether it should replace by mean or median.
Yeah. Just by plotting it only, we'll get all those things. Okay, so yeah, we just
small questions that you answered. I just missed it. What does include equal to all do in the describe function?
In this one, include all will just keep that all the part, all the features. Okay, if we will remove this part, it will just return only the numerical features. Okay. Just
okay. That is how you get category. Okay, thank you.
Yeah.
I didn't know that.
Yeah. So yeah, to get some ideas, all those ideas, we just do all these things. But yeah, slowly, just since you don't have domain knowledge, so yeah, I think.
So why it is showing nan value, like where in the info it shows like no null value?
Nan here is showing how it car name value was that categorical. Okay, so how it will calculate that mean part, how it will calculate 25%. Yes. 50%.
Okay. In the describe we are getting. Okay, perfect.
So yeah, we just got that list of dataset data columns. Yeah, so we got the complete list of what are the different features are there. Okay. So yeah, then length of we just sometime what happens, like you have 205 data set. Yeah, we just simply same data or same value we just copy here. Okay, suppose there would be like we just took some 20 samples and just replace that, like. So now since earlier it was 205 so rows, now it has become 230 rows. So something like that. So yeah, that we can check. And what you will do, like if you have some duplicate data, just think something like that.
Yeah, what is the question?
Like if you have some duplicate data, so what you will do in that case?
That means entire row duplicated, right?
Yeah.
Yeah, ideally we should remove that.
Yeah, that is what you can't do anything, like, because that won't increase efficiency of your model. Just unnecessary calculation will increase, something like that.
Right.
Yeah. So I just
so one doubt, can you go to data describe part?
Yeah.
So here so car ID, why are we getting a nan here? Car ID.
For car ID unique, there is all the values are unique, something like that. It's just like a number here, in some cases.
No, for frequency I'm asking.
For frequency, here you can see that all the values are just like increasing numbers only for the car IDs, something like that.
Yes.
In some cases it happens like there would be some particular ID. It is specifically here in this data set, like it is keeping this one. And does that give any meaning? Like you are calculating the anything related to that ID, but if in those cases,
okay.
If in those cases, like when one same car ID has some different values, something like that, there would be some cases like where for the same IDs different rows are there. Like
because duplicates can also have same IDs.
Yeah, it can happen. They would have some same IDs and they could not have same IDs, because it depends on completely on the ID part. In this data set, what is given, like they have simply just put out the number. Okay, Like just take that case, like the consumer in the bank cases. Okay, so the same persons based on like just take it like that in that case the ID is the account number. Okay, same person can have different transactions. Okay, in that case you have yeah, that count will yeah, then you will see like what is the unique value or something like that.
Okay, got it.
Yeah. So this part I would like to skip here because since you don't have that domain knowledge. Okay, so just to go to the EDA directly. Here what we did is I can tell you, yeah, just we just copied the data and just try to get that car company name and all those things, something like that. Okay. So yeah, let's go to that EDA part. Okay, so what we did here is like first is like a give list of all numerical features. So I think all of you would have already got that. Or anyone have any confusion? Yeah, hello.
So what is the question once again?
No, so that is just describe will tell. Yeah, I don't know about the second question. How do you get only the categorical features?
Yeah, okay, that will see. Okay, so first question, is everyone clear with the first question?
Yes, sir.
Yeah, so it is simply like yeah, just put the list of num-fit. Yeah, so it will give you the part. Okay, so for the second part, list of all categorical features. Okay, so what we did is like we kept here yeah, I just tick that all features, and for categorical features what we did is like we took all those features which is not in the num fit, like we saved the numerical features earlier. Here I think I have,
that's the only way to get it, right? Okay, there is no clean way.
There can be see sir, I can't comment at any place there could be some different way or not. There are many codes like yeah, you can just go through that part here. Yeah, just whatever I at that time just whatever came in my mind, just I put that. Okay, so just you can discuss some logics or some idea, any idea which currently coming in your mind.
We can do a comparison like
Sir, can you please show the num fit again?
Okay.
No, sir, it's just before, I mean, just near the end, you're creating the num feature array, no? Just column, yeah.
Yeah, here only, yeah. Here only, yeah. Here only, just like in the dataset.describe, I didn't put that include equals to all. So it is returning simply only the numerical features only. Are you getting?
Yes, sir.
yes, sir.
Yeah. So yeah. So in the for all feature, we just put dataset.columns. Yeah. Here only we can put like dataset.describe.columns. So yeah, if we will put include equals to all, that will also give that all features.
Yes, that's
Yeah.
what I'm saying.
Yeah. So yeah, for the categorical features, yeah, I for I not in all fits. So yeah, based on this, like we can create, yeah, what are the different categorical features are there. Okay, so just come to the second questions. Type of distribution. So now you have to explore the data, like what you are doing is just think like that only. Now you just want to explore the what is given there in each columns. Okay, so here what we are doing, like we are going column by column. Okay, so like that only we do the IDA part. Okay, so car ID is something we saw that yeah, everything is like given some different car ID. Okay, so what is this emballing, what is this car name, what is all those things like that. How can we get all those data? By plotting, simply by plotting graphs. Okay, at this point the graph comes graphs come to the pictures. So here what I just plotted, like I plotted a graph for every cases, and yeah, I simply what I did here is like yeah, I just marked that yeah, that red line, the mean with the red line and median with that yellow line. Okay, so just try to get some data insights, like what do you understanding by that this emballing part. Okay, there is no meaning of plotting that index part like car ID, so I didn't plot that. Okay, so that's why we put the 1:2. Something like that. Similar.
GCA. Okay, that is a new.
Okay, yeah, you just check it. Okay, so something like that. That GCA will give you that this excess. Okay, this square part is there, no? That comes from here only.
Okay.
Okay. So yeah, since we have just applied this loop, so it is plotting all the parts. Okay, so different, yeah, all the variations of this part. I can discuss all the things, but yeah, I think yeah, it's okay for now. We can skip that part because
Sir,
from
can
here
you
on,
please go to the code before? Yeah, this one.
peak RPM.
Hello.
Yeah.
Yeah, can you please go the code? Go on the code of this question.
Okay, this question's code. It is simply just plotting. I am plotting the graphs, or you can just try it. You can yeah, you can use this for loop also, or otherwise some other things also you can do.
This plotting seems to be like Excel. No, everybody has their own way of. So your way is completely different from whatever we have seen so far. So
yeah. That is yeah. That
everybody
depends.
has their style, no, of plotting.
Yeah. Like you can plot histogram, you can plot box plot based on all the things. Yeah, just put it like if it is just to replace this history with like yeah, box plot. You will get the box plots. Whatever the insights you want to get, no, just to get it. Okay, because based on that also like you can suggest many ideas to the company.
So when do we prefer matplotlib and when Seaborn? I'm actually confused.
There's nothing like that.
Okay.
Yeah.
Like I thought like if one library supports some specific things to plot, then we could use them.
Yeah, Seaborn is like just a more advanced.
Okay.
So can you proceed?
Yes.
Yeah. So yeah, type of distribution your dependent variables follows. That I think I just kept it. Yeah, plot different graphs, histogram, box plot, scatter plot, etc. for all independent variable to get some insight. Okay. So what I wanted was like yeah, you should comments by seeing these graphs. Like what you think here, like what happened here in the case of compression ratio. Why some compression ratio is from here to here. So obviously it will come from the domain knowledge like diesel engine has a higher compression ratio, petrol engine has lower compression ratio. So due to that only like we are getting this kind of graphs, something like that.
But wasn't everything gasoline or there are some petrol, diesel also in this?
I didn't see. I will also see here right now.
So like if you go to the go to that previous, but that's all this plot. Okay, now say for example for this particular column, right, there is a missing value. Okay, what you will prefer, like you will prefer to replace through mean or what?
In this cases, see what I will do here is like see maximum car is diesel engine, this petrol engine only diesel, yeah, it will be a petrol engine. Okay, so maximum car is petrol engine. Okay, so what we will do here is like we will see whether that part is given or not. If it is given that diesel or petrol, if it will be given as diesel, so I will put that value something somewhere near to the 22. Okay, and if it is your petrol part, so then we will put something here, yeah, like 9, 10, something like that. So it completely depends. So are you saying that that is
like,
also not given? Yeah.
No, what I'm saying is like what is this plot actually, like what it is plotting?
Here we just simply plotted the histogram part.
No, that's okay. Like for this diagram, just a minute, this is the compression ratio.
Yeah,
right?
compression ratio, yeah.
Compression ratio plot. Say for example, in this compression ratio plot, in the like when you observe that column, you found a missing value. Okay. What will be the strategy to like fill up that value with mean? Mean is anyway like mean is not representing the data set correctly, even not the median.
Okay, so here see, first thing is like based on these things only your finally output will depend. Okay, so what I will personally here do is like, see, I have some idea of like how compression ratio for diesel engine and petrol engine works. So here we are seeing like, yeah, very few diesel engine is there. Okay, and maximum number of petrol engines are there. Okay, so what I will do here is like, I will see for that cases, since it's a compression ratio is missing, so I will check that whether it's a diesel engine or petrol engine. So something like that is given, no?
So for that you need to write like a manual code, right?
Yeah, for that,
Like
yeah, no, not manual code here. Just see, I'm seeing that is what I'm saying, that yeah, by seeing graph you could have you will get some ideas. Okay, so I think yeah, here they have just that is the two things are there, gas and that. Yeah, it is
correct.
gas.
Now say for example, for that particular column, okay, you see that there are two different halves actually, kind of. One is petrol, another is like diesel.
No, I think
Two different.
I just yeah, I thought like that only, but yeah, right now I think that is gas and fuel type, something like that. They are differentiating. Okay, just to see.
Sir,
Yeah, type one,
is
type.
it this is American, right? So
Yeah,
they
yeah.
are they call different to petrol. They call, I think, gas or gasoline, something like that.
Okay, yeah, it's okay. Just
Diesel, yeah.
we just think it like a type 1 and type 2. Okay. Yeah, we'll take it something like that. Type 1 and type 2. Yeah,
Yeah,
just
so now okay, whatever it is, say for example, like from that data we can clearly understand there are two different types, and the like corresponding compression ratios are concentrated over there, right?
Yeah.
Now when you use a simple imputer, like how will ask that imputer to go and check other column and see like whether it belongs to this class or that class? Like we
No,
cannot
you
write that kind of a code, right?
no, absolutely not. We can't do that.
Okay.
That is what I told you. Like based on these things only your accuracy will depend. And yeah, these things will only impact your accuracy. You should have the domain knowledge, as I told you, like in case of petrol and diesel. Okay, so petrol has lesser comparatively lesser compression ratio. Okay, and diesel has higher compression ratio. So you are seeing just it is written here gas and all. So but just take it something like that only, like type 1, type 2, or just take my words. Petrol. Just take that. Yeah, petrol or some other. Just assume it. It is so one is represent petrol part and another is represent that diesel part. Okay, so here we are seeing like, yeah, 6, 7 part is 6, 7 only cases of diesel engine, and here the maximum cases of petrol engine. Okay, so what we are saying is that we should check that if compression ratio is not given, we will check that. Okay, is it diesel engine or petrol engine? If it is diesel engine, okay, if it is diesel engine, then we will put somewhere near to 22. Okay, and if it is petrol engine, we will put somewhere near to 9 or 10. Okay, so based on that, we
So
predicted.
this becomes a classification problem, no? More than a regression.
Yeah, so, yeah,
No,
I just replaced one value, like something is dot NA, something is there. Then in that case, yeah, we replace that value. Okay. So like
yeah,
that.
but my point is like I understood that part. Okay.
Okay.
My point is like, is there some kind of a these different imputers, right? Can we ask that imputers to do such kind of a conditional check and impute, or it is something that okay, you go through the data and like then manually process it? That means like you need to write some code which will process that. Okay, but I got this as NA, then I will check like these other couple of parameters and then come to some kind of a data.
Yeah, on average, like usually I do from myself side only, like from myself only, like yeah, I just put the codes on usual cases, but I'm not sure there might be some library like, but I don't think so, because no one will tell you like, yeah, on an average. See, just that two cases happened. In one case, what is there, like we didn't see anything. Okay, and yeah, on an average, it put like just replace that median or mid value. Okay, so in that cases also, like, see, since we are seeing that more than 90% cases it is petrol petrol engine. Okay, and we are putting that our that compression ratio value as something like 910. So it is saying that yeah, in 90% cases I will be correct. And it's not like our model is completely dependent on that one data only. That is also taking the average only, no? Are you getting or something? So that told you.
I think in that case, what Rajiv was saying, it's better to look at the features by the, whether it's a gasoline car or a petrol car, and replace the value based on that group. It's kind of a grouping.
Yeah, that will,
that will be
is-
more
So we can
close,
replace it by imputation. Matlab not imputation, but some mean value or something like that we can put over there, right?
Yeah, that is what I said. Like that will give you the more accurate value.
See, but in case of like the imputers that we have studied, right? It doesn't take a condition.
That's why human mind is required in these cases. Like it's no, otherwise it would have completely become like
No. Say for example, you know that this is the condition. You have a very specific. You can specifically like write down that condition. Okay.
Yeah.
But still, imputers, they do not provide an interface like or parameter through which you can pass a kind of a function or condition.
Yes.
That okay, while transforming this column, then you use this kind of a function or use this kind of a condition. That is the point I am trying to ask.
Yeah, so till now I haven't seen anything like that, and I would here in such cases I would prefer this part only. Like since I have knowledge, it should in maximum cases, if it is a petrol engine, I'll put somewhere near to this, and if it is diesel engine, I will put somewhere near to this part. Okay, or that will, I think, model accuracy won't change by significant amount, but otherwise in some simple cases, if I don't have any idea, then I will put mean or median value. In general cases, I told you, like in general, what we do is like we put mean value if not more outliers there, and if we have outliers, we'll put median values. That is the most general cases. Okay. So in general, do like that, and in a specific cases, just I told you here, if I have knowledge about that, then I will do something like that.
Also, if I may, so there is in statistics there is something called multiple imputation. Okay, over there we put this we can put random. I'm not random, but we can put missing values with condition. It's a statistical tool, so I'm sure there might be something in Python too. So I got it. It's called a MIDA spy package. We can MIDA is MIDA spy SPY. Package. There we have multiple imputations options. So if someone is looking for it, so it's a statistical software with multiple imputations.
Okay.
So there's a package called in R. I know there's mice package, but in I think Python it's MIDA spy. I just googled it.
Okay. So what that will do? Something.
So it will give you a choice of conditional imputation. For example, what Rajiv right now said.
Yeah, like that also. There can be a cases, as I told you, like I'm not aware.
Okay, but can you put the name in this chat box?
Yeah, just I'm not sure about though. Okay, but still, this is what there is written.
I'll also.
We can explore actually.
Yeah. So now we just try to check that we just try to plot that independent variable part. Okay. So I think we should proceed first. Okay. Hello.
Yes.
Yeah.
So are you guys coding with me or just listening?
Trying to code.
Okay.
Yeah, we are listening to you actually.
Yeah, even I am listening to. I'm away from my keyboard.
Actually, it would be better if you plot and just what I expected, like this kind of data you will say. I won't tell. Okay, it's okay because time is also 12. Okay. So here we just plotted that price part. Okay. Just here also like I just plotted that histogram. Actually bar plot. Okay. So what we do here is what you can understand from this this plot. Just comment your yeah.
The left skewed, like long tail.
Yeah, that's one thing. Other data, what you can just see from here, and you can suggest something. I'm completely like
We can
yeah.
normalize it. We can normalize the data. So
Yes,
Yeah.
yes. You
it
can center these.
we can we can
Actually, more of
center
an
it.
exponential distribution, right? So,
Just I would say yeah. Just give me that insights, like what you understand from this graph. I have plotted this graph, and what are the information about the price you can give it to me?
It's okay. If you want the statistical distribution, so it seems like a gamma or a beta, like more over a gamma, because of the left skew test, and also I think the data can be easily centered if we just use standard like standard scalar method, and
so there are
and
more
we can
parts.
see with high density, sorry, low price and high density.
Yeah, there are more parts at lower prices, and as more models at lower prices, and as you increase the price, there are fewer models.
Yeah, yeah, that is what I'm what I want from you guys. No, you guys talk in business language. Okay, okay, what I should do and what this data is saying. Just you guys are talking about like some educated person you have who have knowledge of statistics, but I don't have any knowledge of statistics. I am not educated. Okay, so I just want to, yeah, you have this graph and you are trying to convince me. Okay, that's
So we by seeing this, we are saying that we should purchase like cheaper quality but higher density cars, something like that.
No, density is the number of cars in that each model, which means that there are more cars at a lower price.
Okay,
There are
okay,
far more
okay,
models.
okay.
It's a very crowded marketplace. So anything between 10,000 to 15,000 particularly is a very, very crowded place. There are so many models, and beyond 40,000, 50,000, that range, there are very few models at that range, right? So there is a less competitive or less crowded market.
yeah, something like that we can say. And yeah, we can also say, since all these cars are on the market, so yeah, people like yeah, maximum people on an average buy cars near to that $10,000 car. That is like maximum sale, something like that we can say. And yeah, maximum yeah, minimum the price of the
So
car
are
is.
you sure it's 10,000 or less than that? Because I can see the more to be in less than 10,000.
Yeah, that exactly you can talk. I am not
5,000
yeah.
to 10,000. That
Yeah, that
bar is 5,000 to 10,000.
yeah, something like that you can say. Just I was just telling in what format I want answers. That is what I'm saying. Yeah.
Okay, got it.
Yeah, something like that. Okay, so that we can suggest to management to yeah, focus, since yeah, that is there can be based on that they can build a strategy, like yeah, they can as Srinivasan sir told, like yeah, they can focus on making more expensive car, or yeah, since it has demand, something like that. It is a different thing, like what we should do. But yeah, this is what this graph is saying. Okay, so for our algorithm we need to normalize it, and yeah, that is what we did here. Like we simply put that NP locked in or something like that. Yeah, whatever, by using standard scalar you can do that. Okay, so yeah, so our next term is like yeah, that earlier I had told you, like yeah, by seeing that CT highway MPG, all those things are correlated, but I don't understand. Like yeah, I don't have any domain knowledge. I didn't understand from that part. Okay, so what I did is, like, what we will do, like we will plot that correlation matrix. Okay, so this is what the code of yeah, heat map we will plot here. And yeah, okay, so here just I'll try to change that color, because are you able to understand? So I think most of you have, almost everyone of you have the idea of this heat map, what it is saying.
Yes, sir.
Yeah, any person like who is not getting what is this what this heat map is, or something like that? Let's try to change.
Sir, I think we don't need to check all the parameters. We just need to check the price and the thing, right?
Yeah, so again we will go to that part only, like as I told you
Okay, got
earlier, like basic assumption of linear regression. which is like we should not put that correlated features. Yeah, so just comment something like what you understand from this heat map, and yeah. Okay, just I think that's true heavy color. Okay, just I'll change.
So even the analysis itself went a bit more. Even the text, the description part, I couldn't get that.
Oh, description part you are saying? Yeah, hello.
No, that's fine, sir. I'll just wait for your question. Yeah, the heat map is because there are so many features, right? I'm trying to figure out how to interpret the heat map.
Yeah, just I want some answer. Yeah, just some conclusion from your side by seeing this heat map.
So, for example, you want the car length. Okay, no, please continue.
Here the higher number indicates that they are correlated, right? Higher the number nearer to 1, like 0.77. Okay, shows that they are strongly related, right?
Yes, right.
Okay.
So yeah, based on this, like earlier you don't have any domain knowledge. So, but based on this, this plot, you just comment like which are
See,
so car length and car width are kind of correlated. If you see a value of 0.84, so which is obvious because I mean you want to keep the aspect ratio of the car same. So car length and car width is correlated 0.84.
So basically, wherever we are getting these blues, like they are like they should be like we can focus attention there because they are the less numbers and they are not correlated.
Yeah. So our idea, our models will our model want more blue type of data. Okay, so we have to think about that red part. Okay, more the red part, that is more dangerous, something like that. In this
Yeah,
plot.
we can remove them because their correlation is strong, right?
Yeah. So that is what I want to comment out, like which so just by seeing this plot, just to comment like which is highly correlated.
One interesting part I found is that
suggestion.
price and weight are also highly correlated. Doesn't necessarily have to be. See, price and engine size are very highly correlated. Perfectly fine.
Which one? Price and?
The last column, right? That is price with everything else. The price and car weight are also highly correlated. That's a surprising part. It looks like the bigger cars obviously have more weight and they seem to be higher priced.
It is 0.84, yeah, and engine size, yeah. What I am seeing here is like, yeah, it depends on the price. It depends on maximum on the like engine size. More in the like it is around 0.87. Okay, so yeah, that is also, so you can say, yeah, that curve weight is there, no? Where car width you told? Sorry.
No, curve weight. I'm just saying they're also heavier. So maybe because of the bigger engines, so they're heavier. So
yeah, that is what the case is. So it's maximum. Yeah, it depends highly on the engine size. So that is obvious, no? That we also
the horsepower and the city mileage. They are
yeah.
Highly correlated.
So yeah, that's what. And some just I've seen this chart, like we can understand like how car works. Like as we talked about, like city MPG and highway MPG is highly correlated. Like it's around 0.97. So yeah, higher the city mileage, higher the highway mileage will be also there, something like that. So yeah, we should there can be many things we can do. Like we could have removed these things by using that part. By replacing that, as I told, like city mileage there, highway mileage there, we can just replace it by that. Yeah, average mileage, something like that. And
the small thing is, I'm surprised that peak RPM and mileage are very uncorrelated. I thought they will be correlated, but that is, I have to figure out my mechanical fundas.
Yeah, peak RPM and
mileage, I thought they will be highly correlated also. But they are not. They are very uncorrelated, right? They are in blue.
Yeah.
See, the last two columns are mileage. So I would expect peak RPM to be highly correlated with them, but they are not.
Yeah. So yeah, it is saying that more is the peak RPM, lower is the mileage. So that is what we see, no? Like we have like R15 and all. So it has very high peak RPM. Okay. So but
this is not -1 to 1. This is 0 to 1.
Yeah, 0 to 1.
Okay, then low means it is uncorrelated.
Yeah.
or negatively correlated. Sorry. Okay.
Even curb weight and city mileage is also correlated, because I think the more heavy the car is, so you would expect the, so for example, if you're driving a SUV, the mileage will obviously be less if as compared to if you're driving a Alto, say for example.
Yes, yes. Yeah, that is yeah, these kind of insights I want from this from this heat map. Like earlier, if we don't had any domain knowledge, but still by seeing this heat map we can come to many conclusions. Yeah, car length and car weight is also directly correlated, 0.88 here we are seeing.
And even price and horsepower. So I mean, the more cc car it is, the more expensive your car is going to be.
Yeah, it is. We can see here like the more the larger the engine size, more is the price. And since the engine size is large, so obviously that horsepower will be higher. So we can see there will be a good lesson about engine size and horsepower. So here is that engine size.
Stroke doesn't seem to be
clarify.
correlated to anything.
Which one?
Stroke.
Yes, stroke. Yeah.
Everything is low.
Yeah, that is why.
Yeah, that is true.
Here, 0.5 means is uncorrelated, and 0 means negatively correlated. How does it mean? What does it?
Yeah, sorry.
See, when the original statistics that we studied, -1 means uncorrelated, negatively correlated.
Yeah.
+1 means highly correlated, positively correlated. What does 0 to, in the 0 to 1 scale, what does close to 0 mean? It is negatively correlated?
I think it's uncorrelated. I think it doesn't say like which is positive correlated or negative correlated. I think
is
so.
this R square correlation or?
It is the R square.
Okay, then we won't know if it is positive or negative.
Yeah,
we only know that there's a strong correlation.
Because we applied
we can only understand like if we do that scatter plot.
Yes.
Okay.
Yeah, okay.
It's just an absolute value.
So blue means like lesser means no correlation at all.
Yeah.
Right.
Okay. Yeah.
Something like that. We can comment. Yeah. So one thing I will just teach, like to remove that there are many things like lasso regression is also help us to remove that these things. And yeah, here we will use that introduce that term like VIF, as I told you, like since it is not covered in this lecture. So okay, so what we do here is
okay. No, before moving to that, like in this correlation, okay. Now here, like even if we see that like this blue red, like all these things, like we get a initial understanding. But do you think like in this kind of circumstances where like number of features are more, probably we do a PCA over there. Like after this, we do a PCA. So that we get a kind of like most of the features which will be kind of uncorrelated.
So you would be getting like a PCA is completely a different thing. Like a PCA doesn't keep that these two columns, something like that. PCA just mix all the things and he just starts to plot the graphs, plots all the points in some different axes. Okay. So
yes. Like my point is like like PCA will mix up all these, so we lose on explainability.
Yes.
Like we cannot explain that variables.
Yeah.
That is one. From here you get some kind of a business understanding that okay, these are the features they are impacting and stuff like that.
Yes.
But my point is different. My point is where you have these 26 features, right?
Yeah.
With this large number of features, if you are doing like will it be a good idea to reduce it through PCA first and then
No.
do your training stuff like that?
No. For 26, 30, this number of columns we are okay. The problem happens like for image, like one image is like 8 by 8 bit, something like that, and we just flatten it like it's a 64 cross 1, something like that. In those cases, like we got like more than 100 number of features. Okay, so in that cases, like the equations becomes complicated, and in the real world problem nowadays, like we just used linear regression just to get that explanatory part only. This is the biggest advantage of linear regression. Like whatever is happening now, we are able to see that, and in many models are like works on that black box complex. obviously by using PCA, yes, you can increase your accuracy, yeah, increase your performance. But yeah, these things will help you to understand, like as we all are able to understand like how these things are uncorrelated, something like that. But
Yes,
by
yes, like in PCA, like you will lose that explainability.
yes.
Okay.
Sir, just as you're doing absolute of course. So if you just don't do that, you actually get the negative values also. So you get from -1
Yes,
to 1.
yes. That is what I told you. Okay, here we have used that absolute part. So if you will remove that, then it will, yeah, there will be -1 to 1. So here we have used that this part now. So that is what I see. So that is yeah. I just wanted to see that this thing. That is all these things comes under ADA. Like what we do is like by seeing some plots and all. Yeah, you just start commenting, and yeah, just try to get some insights from this part. Okay. So yeah, that part till now, yeah, it's done. Now just create a data frame named VIF, which has 2 columns named variable and their VIF. So are you guys going to code, or I should just show the codes only?
No, sir, we will try the code. So yeah.
Okay, so yeah, just do that part. Like create a data frame named VIF, which has 2 columns. Like first is variable and the second column will be a VIF. So for VIF, just you can just take just yeah, this part you can just okay, it's okay. Also like yeah, from stats dot yeah, stats model dot stats dot outlier, you can import VIF.
Oh, this is variance inflation factor. Okay, I was going to ask you that. What does it mean? Okay.
It is one of the tools like which helps us to remove multicollinearity. It is something like variance of the all the models, overall models upon variance of that particular column, something like that.
This is kind of a step 2 towards PCA. Okay.
Yeah, not exactly like PCA, but yeah, it is also helping you to remove the multicollinearity. PCA is doing something like yeah, he just selected like most important columns, and yeah, if you are asking about that one part, and yeah, something like that, yeah, just think like in 3D you have all the data plotted, and you just want one axis, like from that axis all the data are yeah, from list far from that line, something like that PCA does. And if you have to plot 2 lines, so yeah, that 2 lines thing. It is something like overall variance of your model upon variance of that particular column, yeah, that particular feature. So I think I should proceed. Yeah, so in the is what I'm doing is like, yeah, obviously there is no meaning of like putting getting variant VIF for car ID and price. Okay, so what we will do here is like we will calculate the VIF for all just removing these 2 features, these 2 columns, and yeah, to get it, we will get the VIF of all the features. Okay. Okay, so like that we got this part. Okay, so from here like we will start removing one part at a time. Like on an average, it's a general practice. Like we keep all the variables that whose VIF is less than 5 or less than 10. It depends on the situations, like how many data we get. Okay, so Hello.
Yes. So what is the formula again for VIF?
Variance of overall, variance of overall model, by keeping all the features and upon variance of that particular part. Like here it is like this one is there, no, like symboling is there. So variance of all the overall model upon variance of symboling, something like that it does. You can take it you can obviously read the theory part in details.
Okay.
Okay. Or here, just think from the coding part, just think it like, usually we keep at less than 5 or less than 10. So one thing here, what we commonly do is like, we just think we don't remove all the part, like all the features whose VIF is more than 10 directly. Okay. Because it may happen like, that wheelbase is highly correlated with some other thing. Okay. So when we will remove this part, the VIF will change for other parts. Okay. So why it will change? Are you getting?
No, what is this VIF actually? Is it just like a variance of a particular column?
It is ratio of variance of overall column upon variance of that particular column.
Variance of overall column means like, how can I understand? Say for example, there are two features. Okay. Now
variance
like,
of overall model, actually, not a column. Overall
like
model.
Overall model in the sense like your regression model.
Yes.
In
It's
regression
just,
model, like
just
okay,
to
so
see.
that means you are saying that is equivalent to your explained variance.
Explained variance, I can't say something. Yeah, that is what I told you. Like, because see, I haven't explored that explained variance part. Yesterday, like in the last one also, we talked about this. Okay, so I need to check that whether that is I just know that formula part only. Okay, so without getting depth into that part, I can't comment anything. Okay, so here I can see just I'll suggest, just go that this theory part, and here at least,
Because if you are mixing all the features, then you can say that okay, that is the covariance.
Yeah,
Okay.
if we'll mix with all the features, then obviously we'll say that it's not like that. Yeah.
But anyway, like what exactly, like what is the intuition of this, like what it says?
Okay, so higher variance is something like that, that we have know that the whosoever factor, it's some, just take it like a factor which is just representing you, just showing it like, this part has a higher multicollinearity. So what will happen is like, okay, so
Does it mean the highest factor influences the price the most? The highest value influences the price most?
No, not like that actually. Here you have to remove that high BF means that associated independent variable highly collinear with other variables. Okay, something like that it is saying.
Oh, okay, like car length and car width are very highly correlated, so we can just use one of them.
Yes. That is what that is.
The wheelbase, car length, car width. These are the ones that showed up in the heat map as 0.9. Okay, you can keep one, right? You don't need to keep all of them.
Yes. So if we will do that, then also we can get this. Yeah, by doing that we can reduce our variables. Okay, so this is also,
like in this case 1, 2 and 3 can be just replaced by any one of them. Our model may not change much.
Yeah, our final answer may not change much. And one thing is like that, it's a basic assumption also, like we should not keep that the multicollinear term. Like it says that like all the features are highly uncorrelated. It's in the basic assumption of that linear regression. So what we are doing here is just see, it's like a step by step iteration process. So like first what we see is like the features which has the highest VIF value. Like here we are seeing that is 2828. Okay, Yeah, this is 2828. Okay, so car width. So first we will remove that part. Okay, just this is not, yeah, make VIF data frame. So in the first case, what I did is like I just removed that car length. Okay, so just think it like, yeah, although these things I haven't removed in the first place. Okay, I just removed this and I again just calculated that VIF table. Okay, and in the second case, what we see that so the size has decreased. Yeah, so is it okay? Yeah, so what we did here is like how we apply VIF is like first we remove that part like car length, and in the second term what we will do is like now after removing this we will again get the VIF chart for all the variables. Okay, so what we'll do is like again whose VIF is very high, that we will remove. Okay, so like that after each iteration we saw that something. Are you guys getting something or?
Yeah, getting it, sir.
Yeah, so yeah, like stepwise we will do that part, like yeah, one at a time we will remove. I would suggest always like don't remove all the parts like which is higher than more than 10 at same time only. Okay, remove one at a time, again check the VIF value, again see who has the highest VIF value, just remove that. And before doing these things, just I would say always just yeah, since here we have uh, we have made some different data frame, so now it's okay. Otherwise I would always suggest like yeah, just copy the data, because otherwise it will change values and all to your original data set only, like original CSV file. So
yeah, so by the way, so the data set, so basically what are we passing the data set, that for loop, what is it computing? The list of columns that we want to pass.
Sorry, just
silly question that for I in data set or describe columns, I just trying to parse that. If I not, which means we are excluding these and passing the rest of the columns.
Yes.
Okay, and so that is still a data frame.
Yes. Yeah, this part, yeah, we will get that. Like
that is still a data frame, and that's why I'm trying to find out. So
yes,
data set, if I just remove a couple of columns, that is still a data frame.
Yeah. So let's say data frame only.
Okay, because the input to make VAF DF has to be a data frame, right?
Yeah, that we will do. Yeah, that is what is. Like otherwise, I can also check this. You are saying that yeah, this will be data frame only, no? Yeah, it will be data frame only. I also think that. Yes, it is data frame only. This one, no? Hello.
Okay, get it. Okay, thank you. That's a very neat way. Yeah.
So yeah, like that we will just start removing each VIA part, and yeah, we will get that table. Okay. So at the end we will see here, like particularly in this case, what happened, like I was also like yeah, only two columns only two variables I was able to get, engine size and compression ratio. And yeah, one more was like since I did it earlier also, like I just mixed that both the parts, like city mileage and heavy mileage. So yeah, based on that, I just, since I skipped that part, no, the data preparation part, like there I had done that. So from there, like yeah, I got that mileage part also.
Sir, if we want to increase the number of features, we can increase the sample size.
Increase the number of features. Yeah, that can also work. Yeah.
Because here, that will reduce the VIF.
Yes.
Okay.
Because yeah, 205 only. Yeah, here we have only 205. That is the main reason. One of the main reasons, like yeah, we are able to get only two variables.
Okay, got it.
On an average, on usual cases, it doesn't happen something like that. But yeah. So what here? Yeah, that was a different question actually. The data preparation part, like we just try to exclude the, since see, these are the car names. Okay, so what we are on usual cases, we are seeing that yeah, the first term is representing the car name, the car brand name. Okay, Alpha is there, Audi is there, BMW is there, something like that. Okay, so that was also a question, like yeah, where we just try to get that car company name, and yeah, we'll see that like how the car company name, yeah, based on the different company name, how we got the plot of yeah their prices. I think that was also, yeah, that was also a question actually. Actually just I skipped the one part of question. So yeah, from that part, like we get all the car names, and yeah, all the car names, and yeah, their average mean prices. So here we did that part. Okay, actually just skip that question part. So that's what. Actually, we didn't follow any pattern. Actually, we just started discussing. And so yeah, here we are just plotting the bar plot of different categorical features. What we are doing here is like, yeah, we just checking that this time just to see here, like we are just focusing on that all the categorical part features only. Okay, so what will happen is like based on this we will be able to understand few things. Okay, so we are seeing that maximum cases are yeah, maximum vehicles are on gas type, very few vehicles are of diesel type, yeah, less than 25 actually. So that is what I was saying, that by seeing that graph only, like yeah, since I know that yeah, diesel engine has a comparatively higher compression ratio, so due to based on that I was saying that. And here from this chart we can easily yeah, infer that part. The maximum vehicle has gas engine. Then aspire, yeah, aspire is one counts, yeah, that is yeah, standard and turbo. And here we are seeing yeah, more or less four doors and two doors both are have equal, yeah, in the market both type of car is there almost equal. So I something we can say. So yeah, 40-60 something like that. No. Yeah, hello.
Yes, sir. Yeah, this is something US specific. Yeah, India we won't appreciate it. So
yeah,
we wonder how come having a two-door car is useful, but yeah.
Yeah, that is what, yeah. And there we are able to see the yeah, that sedan has the maximum, yeah, maximum car is of sedan type only. Yeah, and second highest is selling is for hatchback type. So yeah,
Yeah,
this
if you do a hatchback and two-door, I think that probably will be a very high correlation.
yeah. So these things, yeah, these things we can just by plotting graphs we can yeah, infer these things. So these are the parts, like these are the main work as a data scientist you will do. It's not like always predicting supplies that you just that is a proper mathematical part, like yeah, you just put some model, numerical models, and the algorithm just it will just try to focus on, like yeah, it will learn that weight part and predict you the price. It's not always that part only, like all this is like in the industry, like 80% of the time you won't that you will invest your time on that clearing the data and data preparation, and yeah, all the GDA parts only. Very less time we put it in that, because that's like just a code part, no, like you have everything ready, like you just put something in that box, it will give you the code.
So one more doubt on VIF, like
Yeah.
permutation score also, does it do a similar selection as a VIF? There also the assumption is that they're independent, and then I get to know whether certain features are like retaining the independence or not, right?
Permutation features.
Permutation score.
Permutation scores. No, I don't have idea, because the thing is, see, I would say like these are the basics, and we just what happens now, like we just move to the higher terms, and yeah, we start ignoring the lower terms. Yeah.
Okay.
So it is like that only, like we just know these terms were there at the time, but yeah, so that's why we also know that yeah, this is the way of it's formalized there, something like that, and how it works. So yeah, exact comparison, like how it is similar to the explained variance, we also need to see that.
Okay.
Shreya, what is permutation score?
So permutation score gives you this thing. I mean, it starts with the null hypothesis. It kind of gives you a p-value on the correlation of the features, like whether the features are independent or not.
Okay.
So it does a cross-validation exercise using the estimator that you've given, and then determines whether the features are actually independent or not. It gives you a p-value. Based on the p-value, you can decide whether the features are independent or not.
Okay.
So yeah,
We can
then-
also use the chi-square test, right, of independence.
yeah, chi-square test is also there.
Yeah, got it.
So many things are there. I told you, no, like
Okay.
here you are doing these things, and some multicollinearity you can do by directly by seeing that heat map only. So yeah, VIP is also a technique. Or as I told you, like yeah, we can do, to remove these things. Yeah, we can use directly lasso part. Okay, because that is also used to remove that features. So there are many things. Yeah, just I try to just show that how, if you want to apply VIF, how you will apply.
Okay.
So here we are able to see like yeah, maximum car has like a engine on the front part only. Like hardly like it looks like 1 or 2 car has a rear way. Yeah, engine. Yeah. And from here we can see that yeah, engine type OC has the highest frequency. So yeah, based on these things only, like you take the decision, like which car you should make, or based on these decisions, like what should be your strategy to focus that market. Okay. So cylinder counts here we are able to see like yeah, maximum cylinder counts is like more than. Sorry. So yeah, maximum cylinder number is 4. That it has the maximum frequency like more than around 160. Yeah.
I4 is.
Yeah. Something like that. Yeah, we can plot it, and yeah, based on these yeah, these bar plot we should focus. Yeah, we can discuss this thing. Yeah. And yeah, like there was also a question like yeah, how many front engine are there, and engine located on the front part and engine located on the rear part. That was also a question. So since we skipped that thing, so yeah. Average car price of different company name. Yeah. What we did here, you like first we just extracted that car company name by seeing that car name. From that car name features, like we just extract that first term. That was the car name, and yeah, based on that, yeah, we just put it here like yeah, we just group it by company name and your price.me. So we got the mean price for all the different type of cars, different company cars, and yeah. So based on this, there were questions like yeah, this car company has the highest highest price, yeah, and which has the lowest price, yeah, something like that. So I just remove that yeah, price to price, mean price. That is what I did here. So yeah, I think yeah, numerically I was checking here. So to make that column, some columns were there, no, like the fuel type was there, respiration was there, door number was there, drive wheel was there, cylinder number was there. So we just we had to change these things like that, because this 4 is of no use for our algorithm. Okay, this 2 is of no use for our algorithm. This diesel, this gas, yeah, here you can directly apply in label encoding. Here we have written that manually we are providing that 1 and 0, but you can just directly apply label encoding. That will also work here in these cases. Okay, but yeah, this 4 2, yeah, since it's a number, so also we can use that label encoding part, but still it's okay, we can change that.
So the replace thing takes an array set.
Yeah.
Right. So basically, the first is the ID, dictionary key. Dictionary key, and then a set.
Yeah.
So no, complicated. Yeah, this is a complicated.
It's okay. I will just tell you to ignore this part. Okay, just apply directly label encoding. That
okay.
will also work.
Okay.
Okay. So after applying these things, yeah. think, yeah. Okay. Oh, I didn't copy that. Yeah, again, I just copied the data set because I don't want to change all these things in our original data set. So, yeah. So now we will apply the one hot encoding. So can someone just encoding and what is label encoding?
So basically, in a categorical variable, so basically we assign, suppose there are 4 labels, so we appropriately assign 0 or 1 depending on the presence of the label.
Yeah, for which case, one hot encoding or label encoding?
One hot is what I thought I described. I don't know.
Yeah. But I just wanted to see. It's okay. And what about label encoding? What we do here?
So label encoding gives one value, numerical value to each categorical variable, like in the same column. It retains a single column.
Yes, like that only.
One hot encoding has one column for each category.
Each label or each value label.
Not each label, sir. Each category, right? Like
each part of the name.
Yeah.
So suppose like before applying one hot encoding, we had how many number of columns? Just since now we have just
26.
26 was there, no? So what do you think? Like after applying one hot encoding, how many columns we would have? Okay, just don't think actually we have applied one hot encoding for these 3 things. Okay, so just skip that part. Okay, just think like okay, so there we before applying, just we'll apply one hot encoding for this part only, like okay, fuel systems.
One more column will come.
Yeah, one more column will come. That is what I was questioning. Like if there are a number of these things like these labels, so we will get n-1 column, new column. So how are you getting? Do you have idea like how it will happen, or just someone explain that part? I'll be happy to move further after listening that part.
Yeah, see, I don't know how the data set, the column headings column heading will change, but what will happen is suppose you take one, right, the fuel type, gas and diesel. So for gas, you'll take the value 0, so there'll be 0, 0, and then fuel, 0, 1, and then fuel, if it is diesel, it will become 1, 0. So that's how the encoding will be applied. So there'll be 2 columns, right? One for gas and one for diesel.
Okay, yeah, that's true. And yeah, that is the case. So here we just applied the simple after the one hot encoding only, like we got all the data.
So how do they get renamed automatically, the column headings?
No, just we put like prefix we change. Oh, this one like.
Oh, okay, I got it. Okay, you have changed the. Okay.
Yeah, no, but what you are saying, no, that itself takes this part. No?
So body convertible, body hot top, body hatchback, automatically generate.
Yeah, it automatically generate. Like it just take that reference. Like just mix it with this part. Like earlier body was there, convertible, hard top, hatchback, something was there. No, so it takes like a body underscore convertible. So you just make that as a feature name.
Since we're discussing it, why would we prefer one hot over label encoding?
See, in the label encoding, like in the same column only we would have, so that won't give any meaning. Like see, what it understands, your algorithm understands like that numerical number. Are you getting?
Yeah. Okay. I understand. Okay.
So what if we apply the label encoding here? No, like 4 and 6. So it will understand like 6 is something bigger number, so it will give large value to that part. Okay, it will think like, but here it is completely different. No, it doesn't matter it is 4 and 6, but both are different models, something like that.
But isn't that ordinal encoding?
Yeah, that is also we can say, but
label is anyway ordinal, right? So which means we are basically saying there is no actual meaning to the higher value.
Yes, yes,
You don't
yes,
want the skew. Okay, I remember the lecture. I remember Professor Ashish saying that. Yeah, okay, that's why we prefer one part. Okay.
yeah, in these cases, because that doesn't give any meaning, no? Since that is what you told, that it's ordinal. So in that case, when it was not ordinal, so in that case, a higher value would have some higher meanings. So that is what our algorithm will understand. If you will put simply a label encoding only, so it will understand something like that only, like it is 4, it is 6, so it will give more values. So
yeah, so which means suppose I have something called rating or stars, I can use ordinal encoding or label encoding for it. That will be appropriate.
yeah,
Because 5-star, if I make it with 5, it is definitely
exactly
higher than
in
1.
rating and all.
Yeah,
Exactly in rating, in cases of rating.
So for classification, one hot is preferred, is it? Like is
For classification, for different model, to make the different, different feature.
Okay, all right.
So like that we got this, and now we can see that how many number of columns we got. It is 143. Okay, so standard skill also here. I just applied the Discord. That doesn't mean anything. Something new. Because what is the? Have you got till now like why we apply, why scale our data?
What is the question?
Why we scale our data? That is like for our algorithm I'm talking about.
Yeah, otherwise, like if we don't scale our data and bring our mean to 0 and standard deviation to 1, otherwise, like say for example, two columns, age and salary. So your salary will be much higher than your age, right? So whenever you train some algorithm, that will get higher weightage. So it will dominate, and your you won't be able to factor take care of the other feature. So that is the reason, like you scale it down so that everything is in same scale. Now the weights will not go here and there.
No, actually, my understanding is slightly more, sir. Actually, if you are doing linear regressor, if you are using all the features at the same time, it may not matter. The scaling may not matter. But when you use STD, when you use different features at different iterations, you will have to get them all scaled so that one feature doesn't dominate over the other.
Sorry, what you said, Satnasan?
See, because scaling doesn't affect linear regressor, right? It affects the SGD regressor. So the way I understood was, maybe I'm wrong, the way I understood was that if you're going to take all the features and include them in all the iterations, right? Whenever you're doing a gradient, right? It wouldn't matter. But when you do selective features, right? Because when you do the mini batch and all the stuff, you do selective features. In that time, the kind of feature might mislead your prediction. So looks like I'm wrong. So let me read this with my understanding.
Whatever Rajiv said, that is correct only. So what happens here, no? Like, see, suppose as you told, like it is just take it like your age, okay? Or just I might submit some. Yes. So W0 is there, W1 is there, W2 is there, W3 is there. All these things are there. So one column you have something like weight in grams. Okay, just take it something like that. Okay, so that will be a very high value, like 60 kgs means 60,000 grams. Okay, just take its x2 is your weight. Okay, x2 is weight. So in that cases, like you are multiplying some value with 60,000. Okay, and in one cases there was this x1 was something like age. Okay, so here it is like a 60 40 something something in years, like 40 60 something like that. Okay, just you just think age changes like from 1 to 20. Okay, age changes from 1 to 20, how much weight will change, like it's something just take it like 5 kgs, so 5,000 to somewhere like at 20 will be 60,000 something like that. So this much is value. So you just are you getting that point, like how much the variation will be there, like here we are just increasing our value by just 20x, and here we are just something like that. What I'm saying is like it won't give you the exact correct value for this y. Okay, if the scale is different for all the way, whatever is the scale, just keep all the values in that scale only. Like in some cases, like we apply that standard scalar. Okay, there are also like min max scalar. We apply that part also. Like we just what we'll do is like we make all the values from -1 to 1. Okay, whatever is the maximum value, we just keep it, make that 1. Whatever is the minimum value, we make that as -1. So something like that. And yeah, based on this, we just plot all the values, like all our values. So like that only we just bring down to similar scale. Okay, so every value has the same as something like that.
Yeah, and if we do not do that, then the bias in the model will increase.
Exactly. That is what I was saying. Yeah. See, so yeah, that is what I was saying. Yeah, here it is like 5,000 to 60,000. So if you think your model is, yeah, obviously it will depend on weight part also. Like, but your model will highly biased towards that part, like from this weight part.
So does it mean that this will also lead to overfitting?
Yes, overfitting. I'm not. Yeah,
not overfitting, because
yeah.
now here all your features are in the same scale, right? Like
No,
between
if
-1 to +1.
we don't apply any
No, that time your
normalization.
bias will be more. See, imagine like you have two features, okay, x1 and x2. Now think that you have x1 in scale like 20 to 60, and your x2 is in the scale of 10 lakhs to 70 lakhs. Okay, age and salary, I am telling. Now, what will be your model? Y equal to your say for example 25x x1 plus 15 lakhs x2, right? With slight change in x2, the model will be over dominated by the y value will be highly dominated by x2, right? Now, because that it has a 15 lakhs amount is there, right? So what does that mean? Feature 2 is automatically getting some additional importance. So that means feature 1 is not getting important. So you will get into a situation where you have a high bias in the system.
Yeah, I was trying to get in from the polynomial transformation. So for example, if we use higher degrees, the weight of the higher order terms also increases, right? And that will also typically lead to overfitting as well. So I was trying to correlate from that angle.
No. Don't do that. That is
No,
different.
what you are telling is correct actually. If you are getting into higher order polynomials, right? And then you do the scaling, because after polynomial you will be doing a scaling, right?
Absolutely.
Now you have many features. More the features, like number of features whenever you will increase, right? So your say for example you have a lot of training data, so it will try to kind of memorize them, and that time you will really encounter into overfitting. You are right. And that is the reasons you remember, like in one of the videos said that okay, keep interaction only true. That means you are just interested into that covariance part, not the higher orders like square term, cube term,
right.
those terms. Right.
So,
high bias generally results in underfitting, right?
Yeah,
No,
you can say high biased. Yeah, just continue.
Like you are saying, if you have more number of features, say for example 1x, x square, x cube, like that, x to the power 9, right? It will more suffer from like your overfitting.
Correct. I'm saying, like, what I was saying is without any polynomial this thing transformation, if you take as is, then there's no question of overfitting there. Like overfitting is more this thing of the feature transformation rather than the feature scaling, right? I mean,
yes, you can say that, like at a level. Yes.
Okay, got it. Fine.
Whatever you are saying, that is correct. Like if it is high biased, it is obviously it is moving towards the underfitting, because it is just ignoring the weightage of all the other features.
Yeah, got it.
It is giving the weightage to that features. That
understood.
Yeah. Something like that. Okay. So yeah, just we applied that Z score here, and yeah, we just converted this part y against. I think earlier if I would have run that part. So yeah, just we rescaled our features and our target variables. So I think we are getting error. Yeah, features is not defined. Okay, so I think we didn't run that part. Okay, dataset here.head dataset. Actually, some codes are missed. So this is done. Okay, features part, I think. Yeah, just make it as a features. Okay, anyway, you guys are getting what I'm doing here. Like what we did here is like dataset features dot apply. Okay. Actually, yeah, here we have kept that features now. Somewhere near to this we just
Sir, I think we need the new features after one hot encoding.
yeah, that is what I'm saying.
Change the names.
Yeah, new name features. Okay, so because we are just ignoring other part, it is new name features. So yeah, this is what we got as X engine compression ratio, and yeah, we'll apply that log 10 part to the Y variable, and we'll just simply we splitted our data, and now it's
So
like
this-
now we simply start.
Thing is actually less of an issue, right? So the data preparation is more. We need to spend more time on it.
Yeah, that is what I'm saying. Yeah, main part is that data preparation and that EDA part. In the real like problem, that is
That is the takeaway from this session, right? Data preparation takes longer time.
Yeah, that is also true. Like we are giving just very less time to this part. Okay, so yeah, after that, we just apply that our models, because everything is like on the library it is there. So just dot fit dot predict from here onwards you will do it like that only. Like, but just understanding that concept part, like how it is working, those things are important. So yeah, our model is getting a score of something like 0.689. So yeah, that is less, I can say. And yeah, so again, length of what is the length of the regression coefficient, so that we know. And intercept, all the things. Yeah, just I think since time is yours, I think we can do that. So like that, we can just import that all. We just put that mean squared error is there, RMS is there. We are just getting the values of different matrices like MSE, RMSE, R square, adjusted R square, the score of all the matrices. And after that we can apply that lasso part. After that we can apply lasso model also here. And based on that we can check our accuracy, what is the accuracy. And for that lasso, what should be the alpha values? Like we just put all those alpha value and just put cross value distance equal to 5. So based on that, yeah, we can select by checking that part, like which will give the maximum accuracy. Yeah, minimum loss, like yeah, this part. Okay, based on that we can take that alpha values, and it comes around 0.001. So we will apply this one in our lasso model, and we will predict that, like what we get values. And here just I try to plot like what is the actual model, actual value that orange one is reporting, and what is the predicted value, something like that. And then again we calculated mean square and RMSE R score for all the part, like after applying the lasso models. And there we see that yeah, we are getting R square somewhere around 0.85, and in the earlier case what was our R square?
0.65. So 0.85 is the good number, right?
Yeah. So obviously after applying the lasso we are improving our score, but for this 0.97 is on the extreme only, so that's not an.
What is the adjusted R2, sir? Sorry, just a quick question.
Yeah, adjusted R square. Actually, in the R square, like in the last session also I discussed it. Like what happens in R square? No, we can't say like if someone has higher score R square value, like we can't see. What I'm saying is like one has the 0.3 R square, and another model has some different 0.5 R square. It doesn't always mean that like the 0.5 is better and 0.3 is not good, something like that, because it depends on the number of features. As we will increase the number of features, no, that R square will change. So what we do is like we just earlier I was showing my that whiteboard. Was it visible or not? Hello.
No, don't recollect.
Yeah, the thing is, because after later I understood, like I was talking that about no W0, W1, so I was just writing there, but once
no, whiteboard is not visible.
Okay, just is it visible now?
Yes.
Yeah, so that is what I was at that time I was writing here. So what is it? So this case your number of variables. This is your old R square. That R square. And this is your number of data points. Okay. So these are the things are there. So what we did there is like now we the R square was dependent on that number of variables. Okay. That R square score varies due to that also. Okay. So now we have comparison, like when we apply that adjusted R square, no, we just put this K term, included this K term in the formula, just because so that we can refer, like if something is like for adjusted R square, if one model gives you the value of 0.3 and another model gives you the 0.5 value. So it simply means, yeah, that model is better. And yeah, obviously whatever is the difference in these two models, no, that also gives some sense of like, yeah, how good the model is. Like it is saying the model is good and also like how good the model is. That was not in the case of that old one, R square. So yeah, for that only, like yeah, we have to introduce this mainly due to that, yeah, to remove that effect of this K part in that R square. That's why this new adjusted R square term came. So yeah, we again applied that yeah, all the, just to get that alpha. Usually on an average case, like we simply take 0.001. Okay. So here, but still we just applied this part, like that grid search part. Okay, based on that we just got this value. And yeah, something similar we did again for that part, that reach part also. Okay. So here we got our model accuracy was like for R square here was 0.85, and for the rich case it is around 0.87. So here we are able to see that again we applied the elastic set also. So elastic set it is comes around 0.88 for, but yeah, for its for train part, yeah, for air it is coming around 0.91. So overall we are able to recollect here. Yeah, our model is performing well, like maximum we are getting maximum R square value for this part, elastic net part. Yeah, when we apply the elastic net, and the elastic net model is the best one here, and then regressor model is the second best, and something like that only. Like then lasso is the third one. Lasso come at third place, and yeah, this part like normal linear regression come at fourth place. So yeah, if you have any doubt, I would suggest, yeah, you can ask, or I would surely tell that, yeah, practice this, because yeah, I just didn't apply that. Since yeah, this you have pipelines, so directly you can apply these parts, Hello.
Yes, yes.
Yeah, because yeah, these were the parts like which I think I just gave something new, and yeah, this part you guys are already aware. Like in the 2 weeks, you guys covered these things, no? Like it's a simple like a dot fit, dot predict, something like that. Nothing new is there. Like these codes you have already have, like, yeah, you will simply my new tab is visible. Hello.
Yes, yes, we can see the new tab.
Yeah.
Yeah. So yeah, that is the old. Yeah, this is this one only, like loading data set. We have the codes directly. This one. Yeah. That demo. Yeah, California dataset demo where we have already created that pipeline. Directly put it here, you will get the answers. Something like that. After the data preparation and all, like yeah, we have that pipelines and all these things. Yeah, we can directly just put it, and we'll get the scores. So what I tried to new here is like, yeah, I just simply I didn't use the pipeline because since already we have just all the part we did at a different step. Like we just scaled our model. After that, we just applied linear regression, and yeah, regressor, and then lasso regressor, then ridge regressor, and then elastic net. Something like that we did. So what are your observations?
Regarding?
Yeah, regarding this model, and yeah, what you thought like after this process?
No, didn't get your question correctly.
Actually, I was saying that you were working as a data scientist and you have the tables and all. So you got the first thing is you can talk about what is your better, which one is better model. Actually, we didn't see it. I think that is also an issue. Like we should conclude few things from this part, so like which cylinder number, which engine type, what engine location, like what would be the price.
Yeah,
Like
that we understood actually. Like yes, from these graphs, like we can build a story.
Yeah, and yeah, that is what I wanted. Like after this whole lectures, actually the thing is like we whatever I had planned, no, it didn't go like didn't go that way, because what I was thinking like you will do all the coding by your side, and yeah, each and every person will give their whatever he understood from the data and some suggestions like based on that. Like as you talk, no, something like yeah, that guess part is more that as you talked about that price part, like yeah, this price range has the highest cars, so based on that what should, yeah, that is a statement, like that is understood from the data. What is your suggestion based on that? Something like that I wanted, but obviously yeah, you guys didn't solve that code. It's okay. I would suggest like yeah, just practice this code, and yeah, just try to take it like a task only, like just practice this code, and yeah, just try to think like what based on these things, like based on these graphs, what will be your decision? Like just try to get some decisions. Like yeah, I have to make a model. Yeah, I have to create a model. So which model I will create and why I will create. Just think in this direction. Okay, so that will just help you to build your like it will improve your problem solving skills, something like that. Or rest other things are yeah, that's it. Because the other things are just your calculations, something like that. So that is the main part that no one teaches, like because that you will have to after the practice and all these things. Yeah, problem solving skills is something which can't be taught. Yeah, these are the coding parts. That's a different thing. Yeah, it will help you to show your insights in better way. But yeah, you should be able to conclude those things. Yeah, I think so. Can we close this one or anything else?
Sir, I just wanted to ask one thing.
Yeah.
Here we are getting that score is equal to 0.68.
Yeah.
Right. So what does that indicate? Does that indicate that the model predicts with the accuracy of 68%?
I think it would be around like yeah, no. I think this would be something like your R square would be there, sir. Yeah, R square
So this
value
is
there.
R square value 0.68.
Yeah.
Okay. But this is only taken on training data, right? Not on the test data.
Yeah, this is on the training data, and I'm not sure like many code we didn't run now. Just we just randomized many things. No, so I think yeah.
I just wanted to know how do we interpret this score thing?
Okay.
This regression dot score. How do we interpret that number?
Yeah. So from that, okay, go ahead, please.
Yeah. So what we are that R square is saying something like that. So is in the last class also we discussed like this is your base model. Okay, this one is your base model. So this is a random people is talking something like that. Why predict it is base model here. Okay, so what is your base model is every time you are predicting the same value, like whatever I will give you the input, like whatever the features value I will give you will say that yeah, price is 10,000 rupees. Okay, so somehow you got to know yeah, or yeah, any random value. Okay, whatever I will say, you will say that yeah, whatever I will tell yeah, that this is the yeah, there is a car, it has like eight cylinders and yeah, this much engine size, that is the compression ratio, all these things. You will say price will be 10,000, something like that, whatever I will say. So what R square says is like it compares your model with the base model. Okay, and what 1 minus UAV, something that it was, no? Yeah, so it compares your model with that base model. So here V is your base model. Okay, so this is mean square error, and yeah, this is RSS, I think. TSS, sorry. Okay, so what is doing is actually I think I wrote the opposite. No, this one should be T square. So I'll just tell that yeah, that U part is like something like your y1 predicted minus y square, y1 square plus y2 predicted minus y2 square plus y3 predicted minus y3 square. Okay, so this is there, and V is every time this is some just take it value as like a k value. Okay, so what he is saying, k minus y1 square plus k minus y2 square, k minus y3 square, something like that. Okay, so here it is simply saying R square is saying how good your model is if I compare with this base model. This is your base model, no? So if I compare your model with the base model, how good is your model? If it is less than 0, it means your model is so bad that even people who is saying that every time the same value, it is not performing even better than that. So yeah.
So basically, higher the score value, better is the model.
Yeah, but there is one more cases like if you increase the number of features, no, R square tends to increase because see here if we earlier I think yeah, only one value was there. Okay, and now like earlier only one value was there. Now we increase like two more value, like y2 and y3 more came. So obviously R square will increase, no? it increases, like it depends on the features. So that's in that case only like adjusted R square came. But yeah, normally you can say, yeah, that is what if we are keeping that features, all the features same, no, like the fixed number of features. So yeah, R square is, as the R square is increasing, yeah, your model is your model is more accurate.
Okay. Yeah.
That is what. So can we close this session or something else?
Okay.
Yeah,
We can, I think we can close.
Or Rajiv, are you saying something?
Yeah, look, I have couple of questions actually. Okay. So
Okay.
one is like first one is on column transfer.
Okay.
In case of a column transformer, we can like we can give a column like which column you want to do the transformation. Okay. Now, say for example, your first call you want to like process the first column, third column, fourth column. Okay.
Okay.
So I was trying with column transformer, but column transformer I cannot give him like a 1, 3, 4. Okay, like more than 2 if I give, like it complains. Okay, and in a list. So I'm not saying like you need to answer right now. Okay. So since everyone is there, if anyone can can like try it out and like post in the forum, that will be great.
I would always suggest for this type of questions, always use the forum, because in the forums, like I can just see that code and yeah, I can try that, because and
Yeah,
just yeah,
I can do that.
yeah, just put it
Okay.
in the forums. Okay, and yeah, because in the column transfer where we just talked about that part.
Column transform, like say for example, like you want to process 4 column first 4 column through something, and first 4 column is say for example categorical, and
Okay.
second 4 column is say for example numerical, right?
Okay.
So for first 4 column, like you will be using some like say level encoder or something, that one hot or something.
Yeah.
And for others, like maybe standard scalar, right?
Yeah.
So you cannot use just a pipeline, because pipeline like each thing like it takes only 2 argument. So in the pipeline you need to use a column transformer.
So you can do one thing, no, like just I'm not sure whether I'm getting your question correct or something like that. So if here was, you know that dataset.pr is just dataset is there. Okay. See, let me check that whether it is working properly or not. So which column you want?
Say for example, like your car name, and then door number,
Okay.
and car body. Okay. Like
Okay.
more than 2, and they are not consecutive. If they are consecutive, you can give. Okay, you can give as a slice.
Okay,
But otherwise
I think
it is
it
not
works
taking.
something like that.
Yeah. So in column transformer, like you can give these indices, but the problem is like if there are more than 2 and they are not consecutive, right? It is not like giving that. It is throwing an error. That is one.
Yeah, that we can do that in the apply the loops cases.
What is that?
Loop we can apply.
No. Like in a pipeline, you are putting that column transformer, right? You cannot loop it.
What I'm saying is
Okay.
like after applying loop, after applying loop, we'll just save that part in by creating a new data set. What is the solution right now? Coming in my mind, I'm telling that.
Okay. You are saying like okay, before that pre-process and get those things in like contiguous columns. Like yes, that can be done, but I'm pretty much sure like there has to be like
Yeah, there will be.
There will be, because that is like a kind of hand coding. Right?
Yeah.
Rajiv sir,
Okay.
are you trying like pipeline column transformer inside pipeline?
Inside pipeline, yes.
Okay,
yes.
I'll just put in one more. You can use pipeline inside column transformer. I think that works. So for each column that you want to transform, you use the respective pipelines. So that way you can put as many columns as you want. I'll just paste the code. You can try that maybe.
Okay. And specifically, like the problem comes when the columns are not like side by side.
Now here
we
you
cannot
have,
slice that.
you can give the column names itself in this method.
Okay, fantastic.
Yeah, I'll just paste that here.
Yeah, that will also work. Yeah, that part, like where we put that column name. Yeah, that will also work.
Yes. Okay.
Yeah,
Thank you.
something like that. Yeah.
Yes.
Something like that we just here also, no, like for these columns we are working.
But Shreya, I cannot copy these things from here.
Okay, sure. If you put it on the forum, I'll answer in that.
I'll put it in the forum. Okay,
yeah,
perfect.
Yeah, sure. Thanks.
Okay. Secondly, say for example, when we do this linear regression, right?
Yeah.
Now you have, say for example, 10 features. Okay. Now, can we do a hierarchical regression? What does that mean? Essentially, is intermediate in between. I want to learn some good feature. Okay, and then those features I will I will pass it to the output output. Those features I will consider for regression.
I didn't get your point. Just to repeat it.
Correct. I was thinking that way. Say for example, you have 10 features. Okay. Now I want to learn some good features. Now through variance threshold and all these stuffs, like we can learn we can select, okay, get me 3 features or stuff like that. But I don't want to go there. What I wanted to do is I have 10 features.
Yeah.
And my y value is real value, right? Okay. In between, I want to learn 5 features. Okay. Those are combination of maybe linear combination of these 10 features.
Okay. Yeah.
Okay. And then that output I will give it to my final regression. So that means 2 linear regression I'm stacking together.
So for that case, you can do what you can do is like just I told you about that. Yeah, that is the 5 combination of, suppose what I'm writing here is you just create a new column here in the dataset only, like dataset combination. Yeah, just take that as a combination column. Okay, and in that part, what you is doing is like you just put give some weightage of like 0.2 of column 1. It is not a correct word actually.
No, but I do not want to. Yeah, so my intention is not that.
Okay, so what
because I don't know which features will give me which combination of those features will give me good features. Okay, I do not know that.
Okay, yeah.
I have 10 features. Now I will do a first step to select 5 features, but how I will do that is through a linear regression.
Okay, based on the linear regression.
Yeah, that is again through some kind of a some kind of a regression or classification whatsoever it is. Okay, those 5 features, now once I select, then those 5 features are my input to the final regressor.
Those 5 features will be the input to your
final regressor, like so, which is finally going to give you that what you called the y value.
Okay, so that you can from